If you differentiate 2x squared, it will be giving you 4x. If you differentiate x, it is a 1. And if you differentiate 3, it is 0. See it, dear students, whether the denominator is in the form of numerator as if we differentiate. X squared plus 1 is nothing but 2x, isn't it? Because differentiation of x squared is 2x, differentiation of 1 is 0. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on particular function. And in today's session, dear students, here we are having session number 10 and here chapter number 7 called integrals. And what are all the topics we are going to study under this session is nothing but some more problems based on this particular functions. Therefore, without any delay, let us revise into the formulae. Now we are having formulae is given by integral of dx divided by x squared minus a squared is given by log of 1 by 2a into log of modulus of x minus a divided by x plus a plus c. So similarly, integral of dx divided by a squared minus x squared is given by 1 by 2a into log of modulus of a plus x divided by a minus x plus c. Similarly, integral of dx divided by, if you are having a squared plus x squared or x squared plus a squared, the formula will be 1 by a into tan inverse of x by a plus c. So similarly, if you are having all under the root, that is 1 divided by square root of x squared minus a squared into dx, integral of that one will be is equal to log of modulus of x plus under the root of x squared minus a squared plus c. So integral of 1 over under the root of a squared minus x squared into dx is given by sine inverse of x by a plus c, and then integral of 1 over under the root of a squared plus x squared or x squared plus a squared into dx is given by log of modulus of x plus under the root of x squared plus a squared or a squared plus x squared plus c. And these are all the formulae you need to remember to solve the problems. Now without any delay, we'll move on to the problem what they've asked. Integrate 4x plus 1 divided by under the root of 2x squared plus x minus 3. Dear students, see that one is whatever you have taken under the root is the differentiation of that. Yes, if you differentiate 2x squared, it will be giving you 4x. If you differentiate x, it is a 1. And if you differentiate 3, it is 0. So therefore, substituting, put 2x squared plus x minus 3 equal to t. Now differentiate this with respect to x. If you differentiate this with respect to x, you are getting differentiation of 2 into x squared differentiation is 2x plus differentiation of x is 1, differentiation of 3 is 0 into dx is equal to dt. Now here 2 into 2x is nothing but 4x plus 1 into dx is equal to dt. Now you can substitute 4x plus 1 into dx as dt. Let me write this symbolically first, which implies 4x plus 1 divided by under the root of 2x squared plus x minus 3 into dx, which is given by 4x plus 1 into dx is nothing but dt. So integral of dt divided by this we have taken it as t. Therefore under the root t you are going to get it as. Now you can aram se integrate this one. Dt by root t can be written as t to the power of minus 1 by 2 if it comes to the numerator into dt, which will implies t to the power of minus half integration will be t to the power of minus half plus 1 divided by minus half plus 1 plus c. Otherwise, minus half plus 1 minus half is half only. You are getting t to the power of half divided by half plus c. Otherwise, you can get it as t to the power of half can be written. See, 1 by 2, when it comes to the numerator, it will become 2. 2 into t to the power of half can be written as root t plus c. Otherwise, you can have substituted back to t under the root of, we have substituted t as 2x squared plus x minus 3 plus c. And this is your final answer you are going to get for that question. I hope you understood that one. Now we'll be moving on to the next problem, dears. What they've asked. Integrate x plus 2 divided by under the root of x squared plus 1. Now dear students, please observe the denominator is and x squared plus 1 is the differentiation of as giving you x plus 2? No. X squared plus 1 is nothing but 2x, isn't it? Because differentiation of x squared is 2x, differentiation of 1 is 0. Therefore, writing this accordingly, see, which implies, first write it symbolically, x plus 2 divided by under the root of x squared minus 1 into dx. Now, which implies either x squared plus 1 or x squared minus 1 differentiation will be 2x only. Here they have given minus 1 differentiation also 0. Now here I am splitting this one. How I am going to split? See here, integral of x divided by this one under the root of x squared minus 1 into dx plus, see this 2 is there, I am going to take outside the integral 1 divided by under the root of x squared minus 1 into dx. Now you can observe, dear students, this it is in the form of what? I can take this one as I1 plus this I can take it as I2. Now first let us differentiate I1. So I1 can be differentiated by taking, see, if you differentiate the denominator only x squared minus 1, you are going to get x, 2x. 2 can be taken to that side. Now for the I1, I am substituting for I1, okay, let x squared minus 1 equal to t. Now differentiate this with respect to x. If you differentiate this with respect to x, differentiation of x squared is 2x minus differentiation of 1 is 0 into dx is equal to dt. Otherwise, x dx is equal to 1 by 2 into dt. Right? Therefore, writing accordingly I1 as integral of x dx is nothing but 1 by 2 into dt divided by under the root I have substituted as t plus I2. You can aram differentiate. This is in the form of 1 over x under the root x squared minus a squared. So that I am writing as it is integral of 2 into 1 over under the root of x squared minus 1 into dx. Now integrating this one, taking to the numerator, you are going to get it as 1 by 2 into t to the power of minus half plus 1 divided by minus half plus 1 plus this integration will be giving you 2 into log of modulus of x plus under the root of x squared minus 1 plus c. Now here you can have minus half plus 1 will be half only. Along with this half will get cancelled. Let me write that one, half t to the power of half divided by half plus 2 into log modulus of x plus under the root of x squared minus 1 plus c. Now here 1 half will get cancelled, which implies t you can substitute back, which I have substituted as x squared minus 1 under the root plus 2 into log of modulus of x plus under the root of x squared minus 1 plus c. And this is your final answer. You are going to get it as dear students. I hope you understood this one. Now we'll be moving on to the next problem, what they've asked. Integrate 5x minus 2 divided by 1 plus 2x plus 3x squared. See, dear students, whether the denominator is in the form of numerator as if we differentiate. If we differentiate the denominator, see, differentiation of 1 is 0, differentiation of 2x is 2, and differentiation of 3x squared giving you a 6x because 3 into 2. And never you have 6x in the numerator. So what I am going to do here? This I can do it as, see, I can have 5x minus 2. First write this symbolically. Integral of 5x minus 2 divided by 1 plus 2x plus 3x squared into dx. Now I am writing when denominator it is not in the differentiation of the numerator, or you cannot substitute in the form of the denominator, then you are going to do it as 5x minus 2 can be written as a constant into d by dx of denominator plus b or c. Here I am writing plus b since I have taken it as a. So therefore a and b are the constants here. When denominator it is not in the form of the numerator differentiation, we are writing numerator numerator will be is equal to a into d by dx of denominator plus b, which is numerator it is given here 5x minus 2a into d by dx of denominator. Denominator is nothing but 1 plus 2x plus 3x squared plus b. Now here you can have a into d by dx of this will be is equal to 1 differentiation is 0, 2x differentiation is 2 plus 3x square differentiation is 3 into 2x which is 6x plus b. Now you are having here 5x minus 2. Now you are going to take it as this one will be is equal to c. You can compare the to find out the values of a and b. You are comparing the coefficient of x as well as you are going to compare the constant terms. So let me write that first this by multiplying. You are going to get it as 5x minus 2 will be is equal to see 2 into a plus again 6ax, see 6 into ax plus b. Otherwise we can write it as 5x minus 2 will be is equal to 6ax plus 2a plus b. Now here x coefficient here we are going to equate the x coefficient. X coefficient here is 5, here is 6a. Now here comparing the x coefficient, comparing x coefficient, okay, we are going to get as in the left hand side you are having 5, in the right hand side you are having 6a is equal to 5, or you can have a will be is equal to 5 by 6. Now you got a value as 5 by 6. Now what we are going to do, comparing the constant term. So comparing constant term. So what are the constant term we are having? In the right hand side 2a plus b, in the left hand side it is minus 2. Therefore 2a plus b is equal to minus 2. Otherwise you can take, see, b will be is equal to minus 2 minus 2a. Now taking the a value minus 2 into a value is nothing but 5 by 6. Now you can have cancellation 2 3s are, which will become minus 2 minus 5 by 3, which will be a value 3 2s are 6 minus 5 minus 6 minus 5 by 3, which implies b will be is equal to minus 11 by 3. Now b value substituting minus 11 by 3 and a value substituting as 5 by 6. So what we have written? We have written this one, a into d by dx of the denominator. Here we are going to substitute. Therefore, we can have 5x minus 2 is equal to a into 2 plus 6x plus b. Now substituting a value is nothing but 5 by 6 into 2 plus 6x plus b value is negative of that one, so negative of 11 by 3. Plus into minus will become minus. So 5x minus 2 we are substituting this one in the given question. So what was the question? Question was integral of 5x minus 2 divided by, you are having 1 plus 2x plus 3x squared into dx can be substituted as 5x minus 2 can be substituted was 5 by 6 into, I am substituting here 5 by 6 into 2 plus 6x minus 11 by 3 divided by 1 plus 2x plus 3x squared into dx. I hope you understood this one. Now here I am segregating that one. If I am going to segregate, I am going to get it as, which implies 5 by 6 into integral of 2 plus 6x divided by 1 plus 2x plus 3x squared into dx, again minus 11 by 3 is a constant, I am going to take outside 1 over 1 plus 2x plus 3x squared into dx. Dear students, you can remember that denominator it is not in the form of either x squared plus a squared or a squared plus x squared. So reducing that to the form of those by completing square method. Now if you substitute the denominator, you are going to get the numerator. Let me call this one as I1 minus I2. Now I am finding for I1. I1 is nothing but I am substituting. What I am substituting for I1? For I1, Let me take it as 1 plus 2x plus 3x squared is equal to t. Now differentiating this with respect to x, you are getting it as, see, x 2 into x is 2 plus 3x squared differentiation is 6x into dx is equal to what? dt. Now substituting that in I1. So therefore I1 will become, which implies 5 by 6 into integral of, see, 2 plus 6x into dx is nothing but dt you are having, dt divided by this we have taken it as t. Now I2 it is remaining. I2 you have to change it in the form of what? Completing square method. Now for I2 I am writing here, for I2 take the denominator, that is 1 plus 2x plus 3x squared. Correct? Now this you need to do by completing square method. For completing square method you have to make coefficient of x squared as 1. Now to make it as coefficient of x squared as 1, I am going to take 3 outside. If I am taking 3 outside, remaining is here x squared plus 2 by 3 into x. I am writing next extra term plus 1 by 3. I hope you got this one. After making the coefficient of x squared as 1, you have to check what is the coefficient of x. Coefficient of x is 2 by 3, half of that. So half of 2 by 3, which will become 2 will get cancelled, 1 by 3, that squared you are going to add and subtract. Now therefore you are taking 3 into x squared plus 2 by 3 into x plus 1 by 3 whole squared minus 1 by 3 whole squared plus 1 by 3. Now here 3 into this you can have a plus b whole squared. Now which will become a squared plus b squared plus 2ab. Therefore you are having x plus 1 by 3 whole squared. This you can take LCM, plus 1 by 3 minus 1 by 9. So therefore 3 into x plus 1 by 3 whole squared. Now you are getting plus, here 9 will be the LCM. So 3 3s are 9 minus you are having here 1. So therefore you are getting 3 into x plus 1 by 3 whole square plus 3 minus 1 is 2 by 9. Isn't it? Therefore you can have, closing the bracket, 2 by 9 can be written as root 2 divided by 3 whole squared. Root 2 whole squared is 2 because I want to make in the form of x squared plus a squared. Okay. So therefore I can write this one as, which implies 3 into x plus 1 by 3 whole squared plus root 2 divided by 3 whole squared. I hope you got this one. Now substituting that in the form of I2, outside you are having 11 by 3. Already this 3 is there. Denominator I am substituting, so it will become 1 by 3. So therefore 11 by 3 into 1 by 3 integral of 1 over, I am substituting x plus 1 by 3 is already outside, x plus 1 by 3 whole squared plus root 2 by 3 whole squared into dx. So therefore integrating this, 5 by 6 into 1 by t into dt integration is log of mod t minus 11 by 3 into 3 is 9 into, this will become what? Under the root of 1 divided by x squared plus a squared will become 1 by a into, a replaces here root 2 by 3. Root 2 divided by 3 into tan inverse of x by a. Tan inverse of x replaces x plus 1 by 3 divided by a means root 2 by 3. Now further simplification, this plus c. You are getting 5 by 6 into log, substituting back to t. T we have substituted for I1 is nothing but 1 plus 2x plus 3x squared minus, this will become, see, 3 1s are 3 3s are, therefore you are getting 3 into root 2, that is 11 divided by 3 root 2 into tan inverse of, if you take LCM here, 3 3 will get cancelled, 3 taking LCM, 3x plus 1 divided by root 2 plus c. And this is your final answer you are going to get for that one. I hope you got this all steps. For I1 how to integrate, for I2 how to integrate. Now we'll be moving on to the next question, dears. What they've asked. Integral of, let me write this first symbolically, which implies integral of 6x plus 7 divided by under the root of, let me multiply, x into x is x squared, again x into minus 4 is minus 4x, from minus 5 into x is minus 5x, minus 5x minus 4x is minus 9x, again minus 5 into minus 4 is plus 20, because 5 4s are 20. I hope you got this one by multiplication. Now, if you do the denominator differentiation, are you getting the numerator? Never. Because if you do the denominator differentiation x squared is 2x minus 9, correct? Never you are having 2x minus 9 in the numerator. So what I am going to do? I am going to do as usual method as we done in the last case. So I am writing numerator, which is 6x plus 7 is equal to a into d by dx of denominator minus 9x plus 20 plus b. Now here 6x plus 7 a into differentiation of this 2x minus 9 plus b. So therefore you can now compare the coefficient of x and the constant. Comparing coefficient of x and constants. Now first let us compare the coefficient of x, okay? Coefficient of x is nothing but here see 2x into a you are having, therefore 2x into a will be 2a will be the coefficient of x, here 6 will be the coefficient of x. So 2a will be is equal to 6, 2 1s are 2 3s are, so a will be is equal to 3. Now compare the constant terms. In the constant term here see minus 9 into a plus b, minus 9a plus b to the right hand side and plus 7. So therefore you are having minus 9a plus b is equal to 7. You know already what is the a value, you don't know the b value, so therefore keeping b as it is there, 7 taking 9a to this side, it will become plus 9a. Now substituting 9a, you are going to get it as b will be is equal to, see 9 3s are you are going to have, which will be is equal to 27, because a you got the 3. So 27 plus 7 gives you the answer 34, isn't it? Therefore b will be is equal to 34. I hope you understood this one. Substitute a equal to 3, 9 3s are 27, 27 plus 7 gives you the answer 34. So substituting that in the equation, you are going to get it as, therefore 6x plus 7 divided by under the root of x squared minus 9x plus 20 into dx. Under the root of the 6x plus 7 divided by x squared minus 9x plus 20 under the root dx can be substituted as, which will be is equal to, this I can substitute like a value is 3 and b value is nothing but 34. So writing that integral of a is nothing but 3 into 2x minus 9 plus b is nothing but 34 divided by under the root of x squared minus 9x plus 20 into dx. I hope you understood this one. Now segregating the integral, you are going to get integral of, which implies integral of 3 into 2x minus 9 divided by x squared minus 9x plus 20 under the root. Now plus 34 is a constant I am going to bring outside the integral. 1 divided by under the root of x squared minus 9x plus 20 into dx. So now this is called I1 and plus this is called I2. Now here 3 is a constant I can remove outside. Now what do you differentiate denominator? As you know, differentiating the denominator 2x minus 9. So therefore I can substitute for I1. For I1 I can have put x squared minus 9x plus 20 is equal to t. Now differentiate this with respect to x. So therefore 2x minus 9 into dx is equal to dt. So substituting the I1 as like that, which implies 3 will be outside. See 2x minus 9 into dx. Sorry, I forgot to write dx. dx should be there here. 2x minus 9 into dx, which is nothing but dt divided by under the root t. So plus I2, right? So I2 can be written as, now reducing by I2 can be written as, this is not in the form of completing square method. So therefore reducing accordingly, x squared minus 9x plus 20. Now see that coefficient of x squared must be equal to 1. Yes, it is 1. Now see the coefficient of x, which is nothing but 9. So half of that one, which is 9 by 2, squaring and adding, subtracting. So 9 by 2, which is nothing but, see, half of 9, which is equal to 9 by 2 whole square. Now you can add and subtract x squared minus 9x plus 9 by 2 whole square plus 20 minus 9 by 2 whole squared. Now this is in the form of x minus 9 by 2 whole squared. Correct? Now which is a squared plus b squared divided minus 2ab. Now this you can have plus 20 minus 9 squared is nothing but 81 divided by 4. You can take the LCM there, which will become x minus 9 by 2 whole square. Now this is 420. 2 fours are 8. 80 minus 81 divided by 4. So which will come negative x minus 9 by 2 whole square. Now this will become minus 1 by 4. Now you can have x minus 9 by 2 whole square minus 1 by 2 whole squared. I hope you understood this one. Substituting that in I2, you are going to get it as, which implies 3 into, this will become what? Integral of t to the power of minus half into dt plus I2 as 34 into integral of, you are substituting 1 over x minus 9 by 2 whole squared minus 1 by 2 whole squared into dx. Now this will become, this in the form of 1 over x squared minus a squared. 1 divided by x minus 9 by 2 whole squared under the root. Don't forget to write because you are having here under the root. Therefore, under the root of x squared minus a squared gives you log of modulus of x plus under the root of x squared minus a squared plus c. So writing accordingly, you are going to get, which implies 3 into t to the power of minus half plus 1 divided by minus half plus 1. This is plus 34 into log of modulus of x. X replaces x minus 9 by 2 plus under the root of x minus 9 by 2 whole square minus a squared. If you reduce, you are going back to the same form plus c. Now the answer you are going to get for this one will be is equal to, now minus half plus 1 is nothing but you are getting 1 by 2. 1 by 2, 2 will go to the numerator. When go to the numerator, this will become what? 2 into 3. When 2 will go to the numerator, it will become 2 into 3, which is 6. T to the power of half, which can be written as root 2 plus 34 log of modulus of, see, this will become 2x minus 9 divided by 2 plus, if you simplify this, you are going back to the which step? That step only, which is x squared minus 9x plus 20. Therefore, we can write aram say, which is x squared minus 9x plus 20 plus c. Now substitute back to t. What you are going to get it as? So which is nothing but 2 into 3 is 6 root. Under the t we have substituted as what? T we have substituted as x squared minus 9x plus 20 plus 34 log of modulus of 2x minus 9 divided by 2 plus under the root of x squared minus 9x plus 20 plus c. And this is your final answer. You are going to get it as, dear students. Now we'll be moving on to the next problem, dears. What they've asked? Here they've asked integrate. So let me write this symbolically. Integrate x plus 2 divided by under the root of 4x minus x squared into dx. Now is this differentiation of denominator gives you numerator? No. Differentiation of denominator is 4 minus 2x. In the numerator you are having x plus 2. It is not. Therefore, writing the numerator x plus 2 is nothing but a into d by dx of denominator, that is 4 minus x squared, not under the root you are taking, plus b. Now therefore you are getting a into d by dx of this one will be is equal to 4 minus 2x, isn't it, plus b. Now comparing coefficient of x and the constant. Comparing coefficient of x and constant terms. Okay. So therefore, you are getting here comparing coefficient of x there. See, a into minus 2x. So minus 2a in the left hand side, x coefficient is 1. So therefore, you can have minus 2a is equal to 1. A will be is equal to minus 1 by 2, which is minus half. Now comparing the constant term. See, a into 4 is 4a. 4a plus b is equal to constant term in the left hand side 2. So 2. You know already the value of a, b you are keeping as it is. So which implies b will be is equal to 2 minus 4a. Now substituting a value which is minus 1 by 2, minus into minus it will become plus. So b will be is equal to 2 plus 4 by 2, because 1 by 2 will be a value. 2 2s are 4. So b will be is equal to 2 plus 2, which is 4. Now substituting b value 4 and a value a minus half here. You are going to substitute this in the integration. Therefore, you can have integral of x plus 2 divided by under the root of 4x minus x squared into dx can be written as integral of x plus 2 is a value is minus 1 by 2 into 4 minus 2x plus b value is 4 divided by under the root of 4x minus x squared into dx. Now segregating the integral, dear students, what it will be giving you, which implies that minus half will be a constant. Integral of 4 minus 2x divided by under the root of 4x minus x squared into dx, plus 4 is a constant I can remove, which will be 1 over under the root of 4x minus x squared into dx. Now this is I1 plus I2. Now y plus and minus, depending on this, plus is there, plus I have written, okay. Now this is denominator differentiation will be the numerator. So therefore for I1, substitute 4x minus x squared is equal to t. If you substitute this, differentiate with respect to x. If you differentiate this with respect to x, 4x differentiation is 4 minus x squared differentiation is 2x into dx is equal to dt. So therefore, substituting in that, you are going to get it as, which implies minus 1 by 2 is outside. Integral of that, this can be written as dt divided by under the root t. Right? Again, I2 can be written as, see, I2 it is not in the form of denominator completing square method. So by completing square method for I2, you can have 4x minus x squared. Make the x squared coefficient as 1. So taking negative term common, x squared minus 4x you are going to get. Now see the coefficient of x, which is 4. Half of 4 is 2. Whole squared of that one. So adding 2 squared and subtracting 2 squared. You are going to get minus of, this will become x plus x minus 2 whole squared, because you are having here in between minus. X minus 2 whole squared minus 2 squared is nothing but 4. Okay. Now multiplying minus inside, 4 can be written as 2 squared only. Minus into plus it will become minus. Minus into minus is plus. First I am writing that 2 squared. 4 as 2 squared minus x minus 2 whole squared. Now therefore substituting an I2 that one, we are going to get it as, see, plus 4 into integral of 1 over, this will become 2 squared minus x minus 2 whole squared. You are having under the root, so I am writing under the root into dx. Now therefore, this is according to 1 divided by under the root of a squared minus x squared. Under the root of a squared minus x squared is sine inverse of x by a plus c. And this you know already, which can be written as t to the power of minus half will go to the numerator, which is minus half t to the power of minus half plus 1 divided by minus half plus 1 plus sine inverse of 4 into sine inverse of x by a. So x is nothing but here x minus 2 divided by a is nothing but 2 plus c. Now you are getting answer, which will be is equal to minus half here, minus half t to the power of half divided by half. Now half of will get cancelled, 4 sine inverse of x minus 2 divided by 2 plus c. Now you are getting half of will get cancelled, negative will be there, negative of root under t. T we have substituted as 4x minus x squared, 4x minus x squared plus 4 into sine inverse of x minus 2 divided by 2 plus c. And this is your final answer, dear students. I hope you understood this one. Now we'll be moving on to the next problem. Integral of, let me write that, integral of x plus 2 divided by under the root of x squared plus 2x plus 3 into dx. Is differentiation denominator gives you numerator? No. Differentiation of denominator is 2x plus 2. Numerator x plus 2. Therefore, writing the numerator as a into d by dx of denominator x squared plus 2x plus 3 without the root plus b. Now therefore a into this will become 2x plus 2 plus b. Differentiation of x squared is 2x, differentiation of 2x is 2, differentiation of 3 is 0. Now here comparing the coefficient of x and constant. Comparing coefficient of x and constant. So therefore, you are having, dear students, see, you can have 2x into a. Coefficient of x is 2a. 2 into a, which is constant. So 2x into a, coefficient is 2a is equal to, here coefficient of x is 1. So therefore, you can have 1. So a will be is equal to 1 by 2. Then you are having here and the constant term. Constant term is 2a plus b. 2a plus b is equal to left hand side constant term is 2. Now you know the value of a. So b will be is equal to 2 minus 2a. Now you can have substituting b will be is equal to 2 minus 2 into 1 by 2. So 2 will get cancelled. 2 minus 1, b will be is equal to 1. Correct? So b is 1, a is 1 by 2. Substituting that in the integration, integral of x plus 2 divided by under the root of x squared plus 2x plus 3 into dx, which will be is equal to integral of this I can substitute as a is 1 by 2 into d by dx of that 2x plus 2 plus b is nothing but 1 divided by under the root of x squared plus 2x plus 3 into dx. Now segregating the integral, you are getting 1 by 2 is a constant. I can take outside integral of 2x plus 2 divided by under the root of this x squared plus 2x plus 3 into dx, again plus 1 into 1 divided by under the root of x squared plus 2x plus 3 into dx. Okay, I hope you got this one. Now here I can have differentiation of this. This is I1 plus I2. Right? Now for I1, I am taking, for I1, I can have x squared plus 2x plus 3 is equal to t. Differentiate this with respect to x. What happens? If you differentiate, differentiation of x squared is 2x plus differentiation of 2 is 2 is equal to dt by dx. Otherwise, 2x plus 2 into dx is equal to dt. This is for the I1. So therefore, I can substitute, which implies 1 by 2 is already outside. Integral of 2x plus 2 into dx is nothing but dt. So dt divided by under the root t. So plus I2, we have to now reduce to the form of completing square method. Now we can have for I2, x squared plus 2x plus 3. Now see the coefficient of x squared is 1. Yes, it is 1. Now see the coefficient of x. X is 2. Half of 2 is 1. Adding whole squared of that 1 squared and subtracting. So x squared plus 2x plus 1 squared plus 3 minus 1 squared. Now this will become x plus 1 whole squared. Now plus 3 minus 1 is nothing but 2. I can write this one as x plus 1 whole squared plus root 2 whole squared, isn't it? Now therefore substituting in the I2, which is integral of 1 divided by, this will become under the root of x plus 1 whole squared plus root 2 whole squared into dx. Now this will become, taking root t to the numerator, it will become t to the power of minus half, which is 1 by 2 into t to the power of minus half plus 1 divided by minus half plus 1 plus you are getting here 1 divided by under the root x squared plus a squared is given by log of modulus of x replaces x plus 1 modulus of x plus 1 plus under the root of x plus 1 whole squared plus root 2 squared plus c. Now if you reduce this one, it will move back to the same equation. Therefore writing that one, which implies, see, 1 minus half of will get cancelled. So remaining is t to the power of minus half plus 1 is half only. So which is root t plus log of modulus of x plus 1 plus under the root of this will become x squared plus 2x plus 3 plus c. Now substituting back to t, which implies under the root of t we have substituted x squared plus 2x plus 3 plus log of modulus of x plus 1 plus under the root of x squared plus 2x plus 3 plus c. And this is your final answer. You are going to get it as dear students. I hope you got this one also. Now we'll be moving on to the next problem, dears. What they have asked. Integrate x plus 3 divided by x squared minus 2x minus 5. Now let me write this symbolically. Integral of x plus 3 divided by x squared minus 2x minus 5 in dx. Now denominator differentiation is what? 2x minus 2. Numerator is x plus 3, not related. Therefore, writing numerator as a into d by dx of denominator plus b. Now this will become a into 2x minus 2 plus b. Now comparing the coefficient of coefficient of x and constant. Now first compare the coefficient of x. 2a is there, here 1 is there. So 2a is equal to 1, a is equal to 1 by 2. Now a you got 1 by 2. You can have b coefficient which is comparing the constant. See, minus 2a plus b is equal to 3. We know that 2a, so b will be is equal to 3 plus 2a. So we know a is nothing but 1 by 2. So therefore 3 plus 2 into 1 by 2. 1 by 2 will get cancelled. Remaining is 3 plus 1 which is 4. So b is equal to 4 you got and a is equal to 1 by 2. Now substituting there you are going to get integral of x plus 3 divided by x squared minus 2x minus 5 into dx can be substituted as, see that you are going to get it as integral of a is 1 by 2 into d by dx of 2x minus 2. This I am substituting. Please observe, dear students, this what? Plus b. b is nothing but what? 4 we got divided by x squared minus 2x minus 5 into dx. Now segregating this integral, which implies half. First I am segregating this along with this into 2x minus 2 divided by x squared minus 2x minus 5 into dx plus 4 into integral of 1 over x squared minus 2x minus 5 into dx. I hope you got this one. Now differentiating the denominator, you are going to get the numerator which is I1 plus I2. Now I1, for I1, you can have x squared minus 2x minus 5 equal to t. Otherwise 2x, differentiating this with respect to x, 2x minus 2 into dx is equal to dt. Now you can substitute this in the place of I1. So therefore 1 by 2 is already outside. Integral of this will become 1 divided by root t into dt. Correct? So plus for I2 you do not have completing square. You are going to do completing square. For I2, take the denominator x squared minus 2x minus 5. See, the coefficient of x squared is 1. Yes. What is the coefficient of x, which is 2? Half of 2 is 1. Adding and subtracting. So x squared minus 2x. Half of that is 1. Whole squared minus whole squared. So minus 5 minus 1 squared. Now this you can have x minus 1 whole squared, and this minus 5 minus 1, which is minus 6. So x minus 1 whole squared minus root 6 the whole squared. Now therefore for I2 you can substitute it as 4 into 1 divided by x minus 1 whole squared minus root 6 whole squared into dx. Now this will become t to the power of minus half, which implies half into t to the power of minus half plus 1 divided by minus half plus 1 plus 4 into 1 divided by x squared minus a squared gives you 1 by 2a into 1 by 2a. A is nothing but root 6. 2a into log of x minus a, that is x minus 1 minus root 6 divided by x plus a. X minus 1 plus root 6 plus c. Now again here 2 1s are, you are going to get 2 2s are. So therefore here half will get cancelled. This will be root under t plus this will become 2 by root 6 into log of modulus of x minus 1 minus root 6 divided by x minus 1 plus root 6 plus c. Substituting back to t is nothing but we have substituted as x squared minus 2x minus 5 under the root plus 2 by root 6 into log of modulus of x minus 1 minus root 6 x minus a divided by plus b. So x minus a divided by x plus a, x minus 1 plus root 6. I hope you understood this one also. Now we'll be moving on to the next problem here. What they have asked. Integrate 5x plus 3 divided by under the root x squared plus 4x plus 10. Now denominator differentiation is 2x plus 4, which is not the numerator. So writing the numerator in what form? First write it symbolically. Integral of 5x plus 3 divided by under the root of x squared plus 4x plus 10 into dx. Now 5x plus 3 can be written as a into d by dx of, without the root, the denominator, x squared plus 4x plus 10 plus b. Now this will become a into d by dx of, this will be 2x plus 4 plus b. Now comparing coefficient of x and constant terms. Okay, x and constant terms. Now what happens to this? Here you are going to get coefficient of x is here 2a. So 2a, coefficient of x is here 5. So a will be is equal to 5 by 2. And then again constant term 4a plus b is equal to constant term is 3. Now we know the a value. So b will be is equal to 3 minus 4a. Otherwise b will be is equal to 3 minus 4 into 5 by 2. Now 2 1s are 2 2s are, 5 2s are 10. So b will be is equal to 3 minus 10. So b will be is equal to minus 7. Now writing that integral, what is that? Integral of 5x plus 3 under the root of x squared plus 4x plus 10 into dx can be written as, observe dear students, 5x plus 3 I am writing this, a value I am substituting 5 by 2 and b value I am substituting as minus 7. So therefore it will become 5 by 2 into 2x plus 4, b value is minus 7 divided by under the root of x squared plus 4x plus 10 into dx. So therefore here you are going to get separating the integral, which implies 5 by 2 into integral of 2x plus 4 divided by under the root of x squared plus 4x plus 10 into dx minus integral of 7 divided by under the root of x squared plus 4x plus 10 into dx. Okay. So therefore you are going to get the answer here 5 by 2 into 2x plus 4 under the root of x squared plus this differentiation gives you that. So I1 minus I2 because minus is there in between. So therefore I1 here for I1 I am substituting root of x squared plus 4x plus 10 is equal to t. So here you are going to get it as differentiate this with respect to x. Differentiation of x squared is 2x plus differentiation of 4x is 4 into dx is equal to dt. Now substituting for I1 like that, 5 by 2 is already outside. See there you can see. Now 2x plus 4 into dx is nothing but dt divided by under the root t. Now again minus I2. For I2 you are going to take the denominator. For I2. What is the denominator? Denominator is this one. Let me take x squared plus 4x plus 10. Now seeing the coefficient of x squared is 1. Yes. What is coefficient of x? 4. So therefore you are getting coefficient of x squared is 1. 4, half of 4 is nothing but 2, whole squared of that one. Adding and subtracting x squared plus 4x plus 2 squared plus 10 minus 2 squared. Now this will become x plus 2 whole squared plus 10 minus 4. 10 minus 4 it will become 6. So x plus 2 whole squared plus root 6 whole squared. Now writing the denominator as like integral of, you are having outside as 7, 1 divided by under the root of x plus 2 whole squared. Now you are having plus root 6 whole squared, which is in the form of 1 divided by under the root of x squared plus a squared. So therefore this will become 5 by 2 into root t is t to the power of minus half, which is minus half plus 1 divided by minus half plus 1 minus 7 into log of modulus of x plus 2 plus under the root of x plus 2 whole squared plus root 6 whole squared plus c, right? So therefore you can have this here. See, half is there, 2 will go to the numerator, which is 5 by 2 into t to the power of 1 by 2 divided by 1 by 2. 2 will get cancelled, minus 7 into log of, if you do this one, x plus 2, you are going back to the same step, which is x squared, this one, plus 4x plus 10 plus c. So therefore you can substitute back to t here. So therefore 5 into under the root t, root I have substituted as what? X squared plus 4x plus 10 minus 7 into log of modulus of x plus 2 plus under the root of x squared plus 4x plus 10 plus c. I hope you understood this one. Now we'll be moving on to the next problem. Please take this instead of that. Integrate, what is that? Integrate x plus 3 divided by x squared minus 2x minus 5 into dx. Now here I am writing this in the form of denominator differentiation is 2x minus 2, which is not the numerator. Therefore taking numerator is equal to a into d by dx of denominator x squared minus 2x minus 5 plus b. Now writing that one, a into 2x minus 2 plus b. Now comparing coefficient of x and constant terms, so it will be getting you 2a is a constant here, so 2a is a coefficient of x here, 2a is a coefficient of x, x coefficient is 1, so a will be is equal to 1 by 2. We got the a value. Now b value is nothing but comparing the constant, 2 into a minus 2a plus b is equal to 3. Now we know the value of a, b is equal to 3 plus 2a. Now which will become, b will be is equal to 3 plus 2 into 1 by 2, which will become 2 will get cancelled, b will be is equal to 3 plus 1. So b is equal to 4, which is the value. Now you are having integral of x plus 3 divided by x squared minus 2x minus 5 into dx. Observe dear students, this I am writing in the form of this. So a value I am substituting it as 1 by 2 into 2x minus 2 plus b value as 4 divided by x squared minus 2x minus 5 into dx. Now segregating this, which implies 1 by 2 into integral of 2x minus 2 divided by x squared minus 2x minus 5 into dx plus 4 into integral of segregating 1 divided by x squared minus 2x minus 5 into dx. I hope you got this one. Now here, differentiation of this I am calling I1 plus I2. Now for I1, what I am doing? Taking x squared minus 2x minus 5 equal to t. Now differentiating this with respect to x, 2x minus 2 into dx is equal to dt. Now substituting that, you are going to get it as already 1 by 2 is there. 1 by 2 into integral of 2x minus 2 into dx as dt divided by t. Again, you are having plus 4 into, now take the for I2. For I2 denominator, it is not in the form of any of the particular function. Therefore, taking x squared minus 2x minus 5. Okay, now see the coefficient of x squared is 1. What is the coefficient of x? It is 2. Half of that 1. Adding and subtracting. So x squared minus 2x plus 1 squared minus 5 minus 1 squared. Now this will become x minus 1 whole squared. Minus 5 minus 1 is minus 6. Otherwise, x minus 1 whole squared is minus root 6 whole squared. Now root will get cancelled 6 whole squared because I need to reduce to the form of x squared minus a squared. So therefore denominator I can have, already are having plus 4 into integral of 1 over x minus 1 whole squared minus under the root 6 whole squared into dx. Now 1 by t into dt is log t, which is log mod t. So 1 by 2 into log of modulus of t plus 4 into 1 by x squared minus a squared is nothing but 1 by 2a into a is nothing but root 6 into log of modulus of x minus a. X replaces x minus 1. X minus a divided by x plus a plus c. I hope you understood this one. Now here 2 ones are 2 2s are, which will become 1 by 2 into log modulus of t. T is nothing but we have substituted x squared minus 2x minus 5 plus here 2 divided by under the root 6 log of modulus of x minus 1 minus root 6 divided by x minus 1 plus root 6 plus c. I hope you understood this one also. And this is your last session of the exercise 7.4 dear students. In the next session, we'll be moving on to solving some more problems on different types of integration. Keep watching. Have a nice day.